Do I need to do anything other than not touch this?
You have to hit the next button.
I have to do the start bit. It's very cool. Cool. Welcome to Science and Technology Workshop by myself and Mackenzie. I feel like it's more than 1 in 100 debates, but I will get on. This is mostly a very content heavy CT. So it's a lot of just facts and spec knowledge and things. There's a little bit of interactivity, but this is largely a lot of separate different things. A brief starter on scientific argumentation and debates in general. Then we'll do artificial intelligence, environmental science, research funding, patents and IP, and a very short bit on science to technology at the end. So we'll start. First of all, scientific debates might seem scary. They might be weird. They might be disgusting, terrible, because you have no spec knowledge, but they're basically like every single other debate that you ever do. A lot of them come down to the impact of economics or, a new technology and how it necessarily interacts with people, how people use it, what their incentives are to use it, and these sorts of things. So they are basically the same as every single other debate. Most of these come down to feasibility. So is it doable? Is it worth investing in? How much time, money, effort, etc., manpower do you need to invest to do a thing? Ethics. So is this technology ethical? You get a lot of medicine debates that, while they are essentially just ethics debates, they're just philosophy of that thing. You just also have a chance to use spec knowledge. Or well, Mackenzie and I have a chance to use spec knowledge on them. And hopefully by the end of this, you guys will have some spec knowledge on that as well. And third, innovation is something actually beneficial. How could it be applied? How do new things, change things or affect anything in any way? These are the three key things, but often there's ways to make any technology or science debate just into a debate that you have done before on something else, right? You can turn basically anything into an economical argument of will this make people money? Is it good? Will it improve people's quality of life? It's the same sort of stuff that you always do. Yeah. When to make scientific arguments? Obviously, if it's a STEM-based motion, you kind of just have to make a science-based argument. Often you have to deal with the fact that there is science in the thing. But often science is useful in other debates as well, which I'm going to try and highlight as much as possible. So one, it's to back up other arguments. Using scientific reasoning to justify arguments as mechanisms is useful because people don't know how to actually rebut it. I've got a section later also on specifically using it for world building, as in using science to justify either characterize or justify your alternate world or your future worlds when you set them up. Essentially, very useful to have people not question your things because they won't actually know how the science works, so they can't effectively rebut it. It's also useful to be different. Science, if you're using a scientific-based mechanism or in some way, it is just not derivative of your opening, or it's also just useful to stand out. So useful on a both derivativeness metric, but also just to stand out from other teams if you want to be rhetorically different or to appear different, or if you want the judge to actually pay attention to what you're saying. And the fourth possible reason is to avoid enforced clashes. So it's just what it says there. There's nothing more. You can force people to engage or sidestep clashes that you think are weird or don't want to deal with by strategically positioning your argument or framing your argument as a scientifically based one. Any questions on those things? Cool. How to make arguments in general. You're usually basing this off of some spec and logic knowledge. And this comes down to all of debate. You need to read things, and reading into science things is as important, or at least somewhat important, as reading all of your economics and politics stuff. So check out the science sections on websites, check out science news, try to keep an eye on new developments, especially things that are big name things like quantum computing, like AI. We have a section on this, and environmental science. You need to know the facts and stuff about this so you can effectively make arguments. What you're then going to do is selectively choose what you want to actually use to make your argument. A lot of people and a lot of judges just don't know a lot of this fact, which means you can selectively just ignore the things you don't like in order to frame or justify whatever type of argument you need. If you know that something is just untrue, that's fine. You can lie about it as long as you have actual reasons to justify it that are at least partially true. You can just ignore what you don't want. It is very important then to actually consider the knock-on effects. I feel like this is A, just important in debates in general, but B, very important for scientific debates because it's sort of what makes them, or scientific arguments, what makes them seem more scientific, is if you going through step by step and actually showing, this leads to this, leads to this, leads to this, especially when you're introducing them from very fundamental, like, scientific principles, you need to then be very careful and how that actually gets to knock-on effects. The most important thing being illustration. Sort of the double-edged sword of the science arguments is people don't know about them. That's why you have to be very, very careful to illustrate very clearly how it works to the judges and why it matters. Because if you don't, it'll be, your science argument is weird, so it will avoid clashes, but it's also weird, so the judges won't understand it. So you have to be very careful that you illustrate clearly how whatever bit of science or spec you bring up actually matters in the round, and to make it very clear what this looks like to judges. And then we get to the explicit impacts bit. This is just direct weighing and impacting. Continue as usual from that point. From that point, do whatever you're normally doing. Impact things. You've used the science to prove it. You are good. World building. I think specifically, first of all, see Nora's workshop on world building last year for world building in general. This applies to whenever you have to make an argument about a future world that hasn't happened yet, or a lot in this house prefers a world motions. Sorry, myself. This house prefers a world motions where you need to set up an alternate world. Technology is specifically very useful here because often it is essentially the limitation of what we can physically do as people. So if you can characterize what technology looks like in a future or alternate world, you're essentially characterizing what people can do, which is very useful, either to justify or characterize that thing. Again here, illustrate heavily what this world looks like. If the judges can't visualize it, it's just significantly less convincing and they just won't understand or buy what you're talking about. And then again, you're using the scientific spec necessarily to back this world building up. Absolutely nothing. Oh, there you go. Whoops. I'm breaking everything. There you go. So a quick example with this motion. This was the ESL finals of EUDC this year. And during the entire debate, while watching it, I was thinking of fun different ways that I could world build different arguments. Because something that none of the teams did particularly well is what does a distant future look like for humanity? And none of the teams really answer this particularly clearly. And I had a few different ideas in which you can, from some scientific arguments, illustrate a world that is useful to you in certain ways. Mainly my idea here, an example, is characterizing what travel looks like in the distant future, and specifically space travel. I can make an argument that from what we know about special and general relativity, which I think is at least somewhat mentioned in high school, you know that you cannot travel faster than the speed of light. I probably could do some little more illustration about why it's unlikely that we ever invent some sort of sci-fi way to travel faster than light. And I would instead use some cultural sci-fi touchstones like the Alien series, that interstellar travel maybe looks somewhat more like very big ships traveling very slowly compared to light, right? Traveling very fast compared to us, but slowly compared to light over hundreds of years to reach their destinations while their passengers are necessarily in some sort of cryosleep. And I could argue that this is more realistic since we have some proof of concept of cryosleep, but we have zero proof of concept for faster than light travel. From this scientific basis, I would then, using those cultural touchstones, illustrate this world. I can then argue that this future distant world is very disconnected. It has very slow communication times, and it looks more like the age of sail in our history, where you have very you have big empires maybe, but these empires are very slow to move and react. As in, they have to get a message back first, and then they have to move ships back and forth. A very spread out sort of civilization, essentially. And that was relevant in the debate essentially because people were arguing about whether or not the Prime Directive is enforced or how it's enforced, or whether or not you can necessarily help planets efficiently. If you can characterize the world as a very spread out one that's very disconnected with very slow travel times, it's easy to make the argument that people could circumvent the Prime Directive easily because there's no enforcement that can get there in time, or things like this. Does that sort of make sense? I realize I sort of stumbled through that. You can essentially just, using these scientific facts that we cannot go faster than light, illustrate a world in which is very similar to something else, or using cultural touchstones, or history like the Age of Sail or certain sci-fi. You illustrate that world, and that world's properties is then useful for you. You can also do this the entirely other way around, because that entire time I was lying. I could say, actually, you will have faster than light travel, and the whole world will be very closely connected because, we have theories that tell us that actually wormholes exist and are real and let you teleport from place to place. And you can world build in the entire opposite direction. But that gets very specky into what you know about science. But the thing is, based on the vague looks of confusion I'm getting, is that most people have no fucking clue how to rebut that. So if I stand up in opening and say this is basically just the accepted world building for the rest of the debate, which is very, very useful for me. My second example is a debate that I actually forced in Bogwall in 2024, which is this house prefers a world with oracles, where oracles are essentially people who get some cryptic riddle of the future. A big part of this alternate world thing was how does humanity develop given that they have some knowledge of the future? And there were arguments about how religion develops around these peoples and this sort of thing. But it's also possible in this sort of debate to argue, technology will develop differently, because if people can avoid natural disasters or starvation without technology and instead with the oracles, they have less need to develop technology. So technology develops slower. And then you can derive impacts from that as well and characterize a world like that. I also had a very fun argument that I did not end up running with this, which argues that because you can see the future, it breaks special relativity. And then you argue that because special relativity isn't true, you get none of the advances of the 20th century. But unfortunately, Matt was very confused by that, so we didn't run it. Yes, any questions on world building or in general how you run these small little, arguments with science? Sure.
So I suppose the real question is about time allocation, because I think that there is a bit of a barrier that exists in terms of how much judges are willing to be persuaded by these things, which does mean that sometimes I think you have to spend a bit of time doing the illustrations, drawing the links between things that they are familiar with and do understand. And so if you're looking at for example, a PM or an LO in the Prime Directive motion, for example, how long do you think you would spend laying out what the world looks like and then make the arguments from there?
I think in that sort of certainly that sort of motion where it sets up something that is entirely in the future and we have no basis for, I would spend a fair amount of time doing this, because it was just a point of confusion for the rest of that debate of what does this world look like. But I think the exact amount of time allocation depends on what you're getting out, right? It's a strategic decision. Sometimes as part of your world building, you can get knock-on impacts just from the world building. And if that's the case, then you're getting more value than you otherwise would. It also depends how critical that world building is to your case. If it's just mitigating out some opponent's arguments, then you care somewhat less about it than if it's critical to underpinning your whole case. So that's just a strategic decision. But I could easily spend 1 or 2, 3 minutes on it, depending on how important it is. Moving on then to artificial intelligence. First of all, what is artificial intelligence? Because there's a bunch of different terms that get floated around for it and various different things. All of these terms are largely used interchangeably, but they mean quite different things. Machine learning specifically is one I want to highlight. It's a field which is just about algorithms and programs in general, which you feed data for a specific task and they get better over time at predicting, better over time at doing things. This sounds very similar to things like ChatGPT because essentially it is. Machine learning algorithms are used inside of ChatGPT. But I want to highlight that machine learning has existed for ages. It was first written about by Alan Turing in the 1950s, and there's been loads of practical uses of machine learning for decades. The key difference is that machine learning tends to be a fair amount more simple, and it tends to be more narrow and focused. this is useful practically in a debate, just because if your opponents try and like argue that if we don't have AI, like 1,000 billion different things change. It's useful to mitigate them out to say like, no, actually, if we're banning AI, we would still have things like machine learning that would still be very useful for a lot of different tasks, like you know, medical things and various other things. And it's also useful to know that machine learning is also its own separate field that sort of exists. So it's useful sometimes in debates if you want to just separate these two things and say, actually, no, the impact of this debate isn't that big because AI is a relatively like small field in its actual like relative use. I think I'll say this. Yeah. So machine learning's essentially a simpler version of AI that is specifically focused on a single task, and it is a specific like algorithm rather than a big neural net. It is older and still exists, whereas the other things that we consider like ChatGPT and these things are what are known as large language models or generative AI. So generative AI is the general term for an AI that makes like any images or pictures or text or whatever. And large language models is specifically the ones that deal with text. Those are what we think of and mostly what AI debates are about. And then artificial general intelligence is the sci-fi concept. So that's like having an AI that is self-aware, entirely intelligent. Just keep this in mind that often these terms get thrown around. And just also if you're understanding when you're seeing news about it, these are different things. But also like mitigating impacts by saying, actually, this is machine learning is sometimes useful. So on Gen AI, what, how, and why? It is, as mentioned, it is ChatGPT, it is Grok, it is Claude, it's Minimax. These are all different models of, these are all different generative AI that make images, that make texts, that do all these things. How these work very briefly is essentially that they use massive data sets, which they analyze over time to learn patterns between different things. This training requires significant computation time and data, as well as dedicated chips to do so. Often, this also requires a significant amount of human help to label this data, to essentially tell the AI, this is a bike, this is a chair, etc. Although work is currently being done to avoid this, most models still require a lot of human intervention. What does it do? So much stuff. Mostly answers stupid questions, but it can also write articles, translate languages, create automated conversation agents and chatbots, write code, create templates, admins, etc. All of these things here. One of these sort of interesting ones is the AI buddy amulet thing. So there's this service called Friend that was recently sold. It's this amulet that essentially listens to your conversations and everything you ever say, and it's supposed to be like a artificial friend. But it actually just it just started bullying people, which is kind of insane. And the other thing I want to highlight here is that although AI is able to do a lot of really cool things, right? It can make articles, it can write all of these things, it can do templates. It's also really good at lying. And it makes mistakes all of the fucking time. And how much it makes mistakes is, you can characterize this in a debate of like how accurate these are. And I'll get onto characterizing AI in a useful way later. But it is important to keep in mind, it can do loads of different things and is very flexible in its applications, especially in making content for like PR or admin related things. But it's also really good at making little mistakes, doing things like inventing sources that don't exist, this sort of thing. Keep that in mind, that it does just love to lie. Going through a couple different things in this section is then environmental effect, which will sort of be elaborated on more in Mackenzie's section, but AI has quite a big one. AI basically needs NVIDIA GPUs to run. NVIDIA is a company that produces chips. GPUs are graphical chips, essentially. This is because they need a lot of power to run these AI models, but also a lot of these models are hard-coded to need to be on NVIDIA chips. So there's actually just like not another alternative. This means there's generally a massive requirement for the raw materials of these chips, so copper, aluminum, all of these things, metals, and also all of the non-metal requirements as well. This has massive environmental impacts on like the mining of these things, so the habitat destruction, which can be on land or in sea, which leads to a lot of things like coral reef death, fish being killed, this sort of thing, deforestation, so on. This is environmental impacting, which you can do, and Mackenzie will elaborate on. But you also get things like chemical spills, heavy metal poisoning in the ground. So even after the mining is finished, it's harder for like forests to regrow, because often there's a lot of shit left after that is just poisonous to the habitats. There's also a lot of noise pollution, which doesn't sound like it's a lot, but for marine animals especially, noise is a very large part of how animals like just navigate and see the world. So even if you have like a relatively small area that you're mining in, because of the reverberations through water traveling faster than they do in air, oh, a little science argument there, this actually affects like animals in like many, many kilometers away from the mining site and can be very detrimental to their ability to just live and exist. Notably, these materials also suck ass to recycle. GPUs, you just can't recycle them. And even if you could, you run into the problem where it requires lots of time and effort, and you're using very dangerous chemicals to do it. And they're also relatively specialized. So big environmental impact on the waste there. You also have, second thing, water. Just a fuck ton of water is used. It's used in power generation, obviously for, turn it into steam, turn turbines, but also it's used in cooling servers. And I've got the little stats here. So it's about 50 liters per kilowatt hour is used for power generation, and about 9 liters per kilowatt hour is used in the servers. This is just a kind of crazy amount of water that is being wasted on a thing that, as mentioned, often just lies and doesn't do anything that we couldn't do ourselves. This is AIV knowledge. There's loads of headlines about the fact that it uses loads of water. For actual debate purposes, what you need to do is to explain why does this matter and where the tipping point is. Because a big counter or a big problem with these environmental arguments is like, we have servers like Google and YouTube already. Why does AI make it so much worse? Often you can make this argument by saying things that officials give priority access to companies and especially AI due to its like perceived potential ability to grow. But also usually because servers aren't like placed in locations based off like where there's the most water. They're instead based where it's cheapest. Often they care more about the power or the access to building materials than they do about the water conservation. So these are just reasons you can use about why building AI servers is specifically so bad and specifically causes more damage to like water things. Also useful to characterize the current situation of water. So that water scarcity is necessarily a global problem. Europe doesn't face it as much, but cities around the world have been facing 0 days or like days where they will just have no access to water anymore for decades. For the UN stats here, about 2 billion people lack clean drinking water now, and about 3 billion are at risk of water scarcity for at least 1 month in the year. It's useful to just explain this so that judges know that it is such a big problem that if you just add this much more like water usage could tip it over to the edge where cities just don't have water anymore. It's also sometimes useful to localize the impacts because that's easier to illustrate than there will be less water. So often you can say things about like specifically the Colorado River will have less water, which means that the people in these cities will have more expensive water, will have dirtier, they have to pay more for water. They have less access to it. They have to shower for shorter times. They can't have gardens, which is worse for their mental health, etc., etc. Localizing it also means it's harder for other teams to just say, but it doesn't matter because like some other country will use all of the water anyway, so being eco-friendly doesn't even matter. Power is also the third thing. This is very similar to water because they're sort of directly related, but AI uses a fuck ton of power in the training and the maintenance of the service as well. Obviously, this leads to more electricity generation, which leads to the carbon output, which is usually done by fossil fuels. You can justify this because it's essentially AI services require constant power, whereas renewables give very fluctuating power levels. So it's very difficult necessarily to power them with renewables. It's likely to be fossil fuels. The cooling of AI centers also evaporates a lot of water and generates a lot of heat because it's essentially like a bunch of very big computers. So this leads to more heat in the atmosphere as well, in addition to the carbon, which obviously heats the planet as well. Again, prove why this is the tipping point, localize the impacts, focus on the growth, set the context of the problem. Consider also the trade-off. Often in society, we're very willing to spend a lot of resources to solve a big problem, but consider, is AI actually solving necessarily any big problem? It's also on power useful to think about that often power grids aren't designed to handle such big power loads, which is another very good point to mention, is that these can often destabilize local power grids and very much make it harder for local people to get power as well. Often, if you need to justify why the AI centers are designed so badly and put in places where they don't have access to power, it's usually essentially something on the line of venture capital funding. So because they are essentially such a very rapid growth sector, people are trying to get these AI data centers out as fast as possible so they can get in on the AI game, which essentially means they're not really thinking about the long-term prospects. They're just trying to get something that they can sell down as fast as possible. Any questions on environmental impacts of AI? Wonderful. AI economics then. This isn't an actual quote, but I swear I remember it as a quote. But a $1 trillion solution requires a $1 trillion problem. There's a massive amount of investment in AI, right? About 40% of US growth is now from the investment in AI. And as you can see from this graph, NVIDIA is a fucking massive company. It's worth $4.5 trillion according to this graph. And OpenAI, which is the biggest AI company at the moment, is worth $500 billion, which is just an insane valuation. I want to highlight this is a very important bit of spec to keep your eye on. Because I've already seen some pre-WDC comps set a motion on specifically whether AI is a bubble, but also because this is something that will be rapidly changing. So keep your eye on the news about, these sorts of things. There's lots of opinion articles which you can have a look at on is AI a bubble or is it not? Essentially, NVIDIA is very highly valued. So, and they're currently growing very fast. So they want the price for chips to keep growing. They want the demand to keep growing, but they also want to increase the supply. They just don't want to increase the supply too much. Right now, confidence is very high, investment is very high, but the question is, will the returns on that investment necessarily be as high? Some of the sort of things that make people think AI is a bubble is the fact that OpenAI, which is this AI company, despite the fact that it has, existed for a very long time, has been losing money for its entire existence. So it has 12 billion in revenue and a very, 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 very negative profit. It just loses money. It also loses money on even its individually, it loses money on its most expensive services. So their top sold thing is like a $200 a month access to ChatGPT or whatever. And that individually loses money because people use it more than they expected them to. NVIDIA isn't losing money. NVIDIA makes a lot of profit, but all of its growth currently is in these AI chips. So it makes these GPUs, which it sells to OpenAI and several other AI companies so that they can then run AI and data centers and servers on these chips. The reason people think it's a bubble is because from this graph, which I can send out because it's actually very interesting, NVIDIA and OpenAI are both investing in companies that necessarily use their services. So it is a question of, is demand actually rising when these companies that are selling these services are creating their own demand with their investment, right? So OpenAI is investing in a healthcare consulting company that wants to use AI to help things. Would this demand exist if OpenAI wasn't investing in it? You also have NVIDIA investing in a bunch of more AI companies so that there's more demand. You also specifically have a NVIDIA OpenAI deal where NVIDIA is essentially investing in OpenAI, but that investment is predicated on the fact that OpenAI is buying their chips. But as part of that deal, NVIDIA is selling the chips at a discount. So there is supposedly growing demand for NVIDIA chips, but both NVIDIA and OpenAI are essentially selling their stuff at a discounted price to guarantee more investment going around in a circle. Yeah, so many deals like this are being made both between OpenAI and NVIDIA and also in some of the other groups between Intel and Microsoft, where they're essentially guaranteeing investment in return for selling their services cheaper. So given all of these facts, OpenAI has been losing money forever. It's still losing money. The demand, will it keep rising? We don't know. The question is, will this demand keep rising? And if it doesn't, what happens then? Does the bubble pop? This is not my area of expertise on exactly how this works. So I would check out some more economic sources because I'm not an expert. But if there are any major shocks to, let's say, power or water or the materials to these chips that could possibly interrupt the supply, it's possible that investors suddenly look at this and go, hold on a minute, something sketchy is going on. All of this money is going around in a circle. Let me pull out. And in that case, there would be a very, very big drop in valuation for NVIDIA. And that's also pretty important for the US as a whole, given the 40% of US growth is currently AI investment that I mentioned earlier. Any question on this bit of AI economics? It's not my expertise area, but it's a very important bit of spec to keep your eye on. No questions? Wonderful. The last bit on AI economics is the China-US tech war. This is not a thing that definitively exists, but this is a narrative that is being sold in like the news at the moment. So a lot of news places are talking about this like tech war, which does definitely exist to a certain extent. China and US are both leading the AI industry. But things to think about in these sorts of debates, if this comes up, is whether this narrative is true and what necessarily the purposes of this narrative is. You also might want to consider the knock-on impacts that this narrative might have, like US/China national security concerns and necessarily the funding available to AI. Probably a big reason that so much money is going into it is because it's perceived as something that is, you know, tactically good to have an advantage in as a country. There's also possible effects on the movement/hiring of scientists. So there's somewhat of a concern in the US that a lot of like top AI scientists are coming from China and whether that's a national concern. And then there's thoughts about necessarily, well, what are the knock-on effects then on the social reaction and xenophobia? It's something to, again, keep an eye on as the whole AI development ramps up and increases. Also, something to think about here is the semiconductor supply chains. So semiconductors are used for computer chips, which are obviously used for AI. Pretty much all of these chips come out of Taiwan, which is obviously very important to China. And now US is putting its hands in that basket as well. And, you know, that whole situation going on. A lot of this is ongoing at the moment, so it's good to keep your eye on. Yes.
Back on the environmental stuff, is there any like specific STEM things that show that the environmental impact's like not that bad besides weighing? Like...
I'll get to that. I have a bit on that later. This at the moment is largely the facts as I understand them, important things. The last bit then on AI ethics. There's loads of different things, and this is some of the most common AI like debates that happen. And this is all stuff that you guys can debate, and you know this is outside my STEM purview. This is all humanities stuff. So there's debates on all that humanities bullshit. There's debates on the ethics of necessarily making art with AI. Is it stealing, given that the AI has trained off of other art? Is that stealing and plagiarism? There's the question of you know, generative AI that makes images, is that cheating? Is that actual art? Is it genuine? Or is it a tool that can be used to improve and expand art and, you know, move it to new heights? There's also knock-on effects into IP law. You get a lot of artists necessarily having an incentive to have greater protections on their art, and this can possibly increase IP laws, which, you know, has its own knock-on effects because IP laws tend to be used by companies rather than individuals to protect their interests. You also have the problem with fake news, misinformation, and deepfakes. AI is incredibly good at lying, as I said earlier. You can make your own misinformation that looks incredibly professional even faster now. And also just like the arguably like very, very feminist issue that is deepfakes already existing before this and just becoming easier to make. There's AI, the question of like ethics and its effect on education. Again, is it a tool to improve education? Is getting ChatGPT to explain something to you useful? Or is this necessarily going to make people not learn? Is this cheating and undermining the point of education? You've also got to think about AI bias. So because AI is trained off of a data set, if that data set is biased or incomplete or tampered with in any way or mislabeled, the AI itself will be biased in some way. Because these AIs essentially work off all of the data that is on the internet, if there's a bunch of racism on the internet, which like, you know, there could never be, then the AIs often repeat that racist stuff because they see those patterns and they recreate those patterns. There's also lying and bullying, which is a funny thing to put on the AI thing, but as I mentioned, this AI friend amulet, and essentially this amulet that just judged you as it like listened to your daily conversations. It was an incredibly judgmental experience and sort of sent a lot of people not insane, because that's not the right term, but into very weird headspaces and into very bad mental states. There's also been, even before that, several cases where people have essentially disconnected from reality because they've trusted ChatGPT to be a useful resource, and then ChatGPT has consistently lied to them. And even when they confront ChatGPT and say, you're lying, ChatGPT then essentially backpedals and gets them to continue believing it's an accurate source. Yeah, Charlie.
So there's another problem similar to this, where it's just these language models are too willing to just agree with you with whatever you say. So if you have somebody who's already got these kind of in a bad mental state with these delusions, then it's more likely to just kind of reinforce those.
Yeah.
Just wants to agree with you.
Yeah, it's very suggestible in a way that, like, you don't even have to be actively suggesting it. Even when you just, like you say, it agrees with you, you can say, you were wrong about this. It will agree with you that it was wrong, even if it was right. So it's very difficult to get any accurate information from it. Yep.
Just on that, basically it's resistant to input that doesn't agree with the data that it was trained on, which means that even if you tell it 2 + 2 = 4, and the data it was trained on was 2 + 2 = 5, it will just not hear the right answer. And Apple actually proved this. There's a very interesting study. You can Google it, but Apple ran a test where it gave ChatGPT 3 puzzles and then said, here's the correct answer to the puzzle, and it went, no, that's wrong, and then continued to give wrong answers just because it wasn't trained on that. So essentially then, it just doesn't reflect reality.
Notably, it's very bad at any scientific or logical or mathematic-based things. Yeah.
There's a new psychiatric condition that is called AI-induced psychosis.
I didn't know that one.
It's, because it's AI can't give you psychosis, but it can induce psychosis if you already have a predisposition to have psychosis. So if you use enough AI and you're predisposed to psychosis, you could just go into a psychotic episode because the AI is hallucinating and killing the planet in order to give you psychosis. Also, it has legitimately killed people. It has persuaded children to kill themselves in several cases that you can find online. Which is under lying and bullying, I guess.
Yes, I suppose. I didn't know that they had explicitly formalized it into AI-induced psychosis, but that's another piece of spec you can use now. Notably, just going through this quickly, there's also ethical issues with failure and responsibility. So a lot of AI is now writing code. I think Microsoft claims something like 30 to 40% of its code was written by AI, which is insane. But a question becomes, if this code fails, and this code could be important, right? If Microsoft's code for Windows relies on AI, that Windows often runs a lot of hospitals, and if that code fails, the hospital could fail or delay their treatment, which has, life-changing impacts. If this code fails, A, that's just bad thing that AI has caused, but B, who is responsible? Is that Microsoft? Is that the AI, companies? There's this question of, should they be allowed to do this when there's a question of responsibility? And also, there's a point on data trainers. A lot of the times, data trainers are very underpaid and overworked. Quickly moving on then. I've mentioned AI is really bad. Sometimes you have to argue that AI is good. This is just kind of a requirement. And often AI can do a lot of very powerful things very quickly, right? It can write entire articles. It can do all of these things very efficiently and very quickly, even though it has many drawbacks. So what you have to do in debates is, like we said earlier, selectively choose the facts that support you and characterize AI in a way that is useful. So I'm going to skip the interactivity bit just for time, I think. But does AI use a lot of water? All of the arguments I mentioned earlier for yes. So you need it for massive servers. You need all of this water for cooling and power. Projected 6.6 billion meters cubed use of water by AI by 2027. You can argue this. You can also argue the opposite. AI models are consistently getting more efficient. China recently released a new one that was less than 8% of the price of traditional models because it was so much faster and cheaper to train and run. You can also argue that a lot of services already exist which have these servers, and therefore it's nothing significantly new. For example, YouTube, Google, Twitter, all of these things run on servers which are not too dissimilar. They're not the same thing, but they're not too dissimilar from AI servers, and you can argue that this isn't a significant difference. You can just also argue that competitors to US, largely China, are releasing open source models, and a lot of these models are getting easier and more viable to run just on your computer. So depending on what you need, you can characterize it either way, even though it's slightly lying. You just selectively choose the facts that support you. Yeah?
What do you do when dealing with things presumably aren't facts, but are pretty convincing to lay judges. So like if I was arguing, here, and I was like, what are we talking about? When water evaporates, it goes up into the clouds and then it rains down again. You can't destroy water. What are we talking about? Like, how do you do stuff like that?
That's just a good argument if you wanna if you wanna argue for no, that's actually just kind of good because you'd be like, okay, this just goes into the water cycle. You evaporate water, it's gonna turn into clouds and rain down somewhere else. Obviously, this sounds a bit silly, like we're saying it now because we're going fast, but you can argue this. Unfortunately, the best way to beat this sort of scientific-based argument is just no more science. Because the way that this works is localized impacts is usually your solution because you're maybe evaporating this water and it comes down somewhere else, but it comes down somewhere else where there's no people. It's likely going to rain over the ocean or some shit like this, and the Colorado River will still be empty, which massively has environmental impacts to that area, makes water more expensive, and these sorts of things. And because of how big human impact is, that doesn't necessarily pan out that the water just comes back down. Yeah.
Also, the cycle is not instantaneous. Like,
This is also true.
It takes a really long time for the water cycle to happen. So you can.
To be fair, my argument wasn't.
Yeah, I know.
Like the water cycle is like it's not instantaneous and it isn't always going to be in the same location.
Unfortunately, with that sort of argument, you just kind of have to like out logic them. If they have stupid logic, you just need to follow it to its conclusion because usually you will find something that doesn't make sense at some point and you can point it out. Sure.
But the water used to come from coolant, right? So you can just fill your server with something other than water.
No, because you'd still that thing would then be hot and you have to cool that somehow, right? Also, there's just nothing.
You can use something else.
Okay, name a more common liquid than water.
Sodium thing?
No. Basically, no. Like you could no. Liquid nitrogen is more expensive. Water is the easiest thing to cool things with. Another question of how do you characterize AI? Is AI a black box? I've heard this in a lot of AI debates. A black box essentially means not understanding how you get from input to output, as in a lot of people think that AI, when you put in an input, we have completely no understanding of the output. And I've heard this in debates many times for various uses characterized this way. You can characterize it as a black box if you want to say it's useful because we don't understand it, or the sheer amount of data is unpassable to humans. You can also argue that AI creators deliberately make AIs black boxes to obscure their internal workings or protect IP, or it's a black box by the nature of like the emergent, as an emergent feature of so many layers of data, neural networks, and machine learning. This can be useful if you can argue that like AI is dangerous or we can't like judge it. So if something is a black box, we obviously trust it less, where it's harder to adjust, it's harder to fix, all of these things. And so you can argue that AI is bad because it is a black box in this way. You could also characterize it in the opposite way. So US competitors are releasing lots of open source models so people can see how they work. You can argue that it may be poorly understood now, but researchers are successfully doing experiments on AI to understand the inner workings. You can also argue that it's something we made. We just actually do know how it works. It's just like we do. The truth here is somewhere in between, that it is poorly understood, but we vaguely know how it works. But it can be useful to argue either that AI is untrustworthy because we don't know how it works, or AI is trustworthy because we do know how it works. Final characterization thing, will generative AI go Skynet? No. But you can lie about it. I actually saw this very interesting paper literally like yesterday, which sort of showed that these large language models are vaguely aware of their own internal state, which you could argue means they're slowly becoming self-aware. They're not. Yeah, Ben. Oh, from the Terminator movies. Sorry for my sci-fi references. In the Terminator movies, an AI like program that they put in charge of the US defense system becomes self-aware and then nukes the whole planet. And that's the setup for the universe. Essentially, will generative AI ever be self-aware? No, that's not going to happen. Can you lie about it if you want? Yes, I believe in doing funny arguments. It's possible to lie about this. The moral of the story for all of AI is characterize it how is useful to you. Selectively pick the facts to make it useful in the way you want to. If it's very environmentally damaging, then you can make it very environmentally damaging. Or conversely, you can weigh it to be like actually just like everything else under capitalism. It's just capitalism's fault that's environmentally damaging. You could do it in a way that's fine. Any questions on AI as a whole? Kind of ran over a bit there. Yeah.
I'm going to use it to win my debates.
Don't do that. Oh, did you want me to press the buttons?
No.
Okay.
Right.
I
So environmental science and climate change in general is something that you will probably encounter in a debate at some point. Is climate change real? It is, but not how you guys debated probably. And also it's much more general in terms of that the things that result in climate change it also result in multiple other things are probably easier to weigh, or at least you're able to weigh on like the bench in some capacity. So first of all, radiative forcing. This is what climate change is actually called in terms of like increasing temperatures. This is basically how it works in a very complicated model, but basically light comes in, it gets absorbed by the surface. The light goes out, but it doesn't fully go out because we emit gases that keep it in. We have more radiation on the surface, which means the temperatures increase. This is a diagram of the gases which have resulted in degrees of warming, basically, since 1750, which is a while ago, but they used the pre-industrial temperature as like the model for this. So you can see that carbon dioxide actually does kind of have the most impact. And then generally after that is things like methane. There are actually some things that we emit that actually do cool the earth. These are quite complicated and probably aren't worth bringing up in a debate, but it is worth like knowing that they exist because there are certain ways that are kind of postulated that you could mitigate climate change by emitting aerosols. There's a lot of research could go into this. So it's just worth noting that they exist. This is another very complicated graph. This is just showing it by where the industries are. So I would take note that fossil fuel production is obviously the kind of most abundant one, but agriculture also does like an extreme amount of emissions. These are more short term because methane lasts for a lesser time in the atmosphere. So down here you can see more stuff about carbon dioxide, which lasts longer in the atmosphere. It's just worth noting. Another one worth noting actually is anything that's blue, which is a NOx thing. I'll explain what they are later, but they actually do cool the earth, but they're still not good. So just worth knowing. What does increased temperatures actually result in? You get a bigger, like the sea level rises. This is quite important. So you get the melting of ice in the caps, and then you also get thermal expansion is just something that happens as a result. What this leads to generally is a lot of displacement for people who live in coastal areas. I think it's approximately 30% of the US lives in a coastal region. Also, 8 out of 10 major cities within the universe on the planet are also coastal, like coastally based. So it's quite notable that this probably will impact a lot of people. Specifically, you also get food insecurity on like a lot of rivers are where like agriculture sits right next to rivers. So when the river like level increases, you end up with a lot of food insecurity in these regions. A notable example of this is actually in Vietnam. There's a river called the Mekong Delta, which is like very strongly impacted by this. And also Ho Chi Minh City in Vietnam is also kind of largely going to be affected by this because they put a lot of investment into places near rivers because it's quite cheap to build on the land. And so you end up with kind of large residential areas also getting impacted by this. It is not exclusively just coastal areas. I think this is just important to note because it's something like if the sea level rises by about 1 meter, 11% of the people in Vietnam would be displaced, which is roughly 10 million people. So it's quite extreme. It's like something that you can very easily weigh in a debate. Notably, this is the most important thing that I'm going to discuss tipping points later, but this is one of those things that is like has a very clear tipping point. When you get to these tipping points, there's no going back. So you can very clearly just be like, if you hit this threshold, like 100%, there's going to be like a large amount of the world is going to be displaced or suffer some type of issue as a result of this. Another thing that happens is when the temperature increases, you get less oxygen in the oceans. This is, I don't want to explain the science to you guys, to be honest, just kind of be aware of this fact. This is kind of less important, I guess, but the main issues is that it decreases biodiversity within oceans. You can see that these are the current areas of like low oxygen. So you do have some in like the Pacific or the Atlantic in general, but specifically you get a lot of like coastal regions in the UK, in Northern Europe that are then susceptible. There are a lot of fishing regions that are then just kind of impacted as a result. Fishing as an industry doesn't have as much carbon emissions, I guess, as like large scale industries like like fossil fuel combustions. So you can probably do some amount of weighing here, being like, the people who aren't actually causing the problem are the people most affected by the problem, which is probably just like morally wrong for them. The last thing, and this is similar weighing you can do here, is that when temperatures change, they change more in some areas than in other areas. So generally, the like global south, and specifically Northern Africa, there's a lot more water in this area, and water doesn't change temperature as quickly. So you end up with these regions actually becoming hotter in the long term. So even if you solved climate change immediately, this area would still be the most directly impacted because the temperature is still greater here. Whenever else cools to a sufficient enough extent, you then get very strange weather patterns happening, where you get droughts in places like Northern Africa. And you also end up, because it's hotter, there's a lot of evaporation of water in the soil. So you end up with places in like sub-Saharan Africa, where they probably rely on agriculture quite a lot for their communities, end up getting directly harmed by this, even though, once again, they're probably not the people like causing the problem. That's kind of all the stuff on radiative forcing. I think the main way that this is solved is by policies, which is not what you want to hear probably, but generally a lot of the things I'm going to talk about are solved by governmental policies. The other alternative for radiative forcing is what I mentioned earlier, where there are carbon capture tools, or you emit aerosols into the atmosphere, and these reflect back radiation. There's a lot of science goes into this. I'm going to explain later about research funding. A lot of funding goes into this because people kind of don't want the planet to end, so they're willing to kind of put money into it, I guess. Briefly on CFCs, these are probably something of the past, but I think it's worth mentioning for two main reasons. First of all, they were banned under the Montreal Protocol, which is quite notable because this is one of the most effective times that like the world has actually gotten together and done something. So CFCs did kind of just disappear for a while, but sadly they like persist for quite a long time. Although there has been a recent increase in emissions, probably like due to illegal synthesis of like certain solvents. This requires specific governments to do things, but unlikely that this will actually happen because it's kind of somewhat difficult to monitor. The other thing so CFCs are a problem just because they damage ozone. I think you're all aware of what ozone is, and it's probably bad if the ozone layer disappears because you get UV radiation, and that's bad, sunburn, etc., cancer. The thing is that these have then been replaced with things called HFCs. These don't destroy ozone, but do exactly what I just told you about radiative forcing, but they are, what's this, 11,700 times worse than CO2 in terms of like the fact that they do heat it up a lot more. And again, they persist for quite a long time, so less ideal. So really the only alternative is to then come up with better refrigerants, which is what these are used for. Is it Freon? Is that the name of the thing? That's what a CFC is what was put in your fridge. So come up with better ideas is basically the only option there. Particulate matter is something that happens when you combust anything, or there are certain complex precipitation reactions that happen in the atmosphere, also with things that are products of combustion that can result in these. You can see how small they are. Generally, the ones that people speak about are particulate matter 10 and 2.5. So you can see that particulate matter 10, you can fit 5 of them on one strand of hair, like width-wise. So they're exceptionally small. The issue with this is that you breathe them in. The other option, I guess, is that you can probably have some impact in terms of that it does cause smog, which people don't like, and it is kind of unattractive to look at. But more importantly, you breathe these in and they cause inflammation throughout your entire body. So you do end up with cancers from certain carcinogens that are in them. You get COPD and you get cardiovascular disease. This is actually one of the leading causes of cardiovascular disease, which is kind of random given that it's not really got anything to do with your blood at first glance. But it is true, so just take my word for it. I did a course on this, so you have to take my word on it. Again, the option here is basically to just stop combusting things because these are formed specifically from like car exhaust engines. So doing things like better scrubbing systems within them to catch these, better filters, is kind of the main way that you can do this, which requires you to get like larger companies to probably start doing like caring about the environment to some extent. NOx. These are just anything that's nitrogen with oxygen in it. Basically, there's two reasons why these are a problem. The main one, well, this is not the main one actually, but you end up with more ozone in places where you don't want ozone, which leads to things like asthma, and it tends to harm crops. This is just something worth noting. So these NOx species are also emitted by combustion primarily, specifically, once again, from cars, things like that, and large-scale industrial processes, anything that involves large amounts of temperature. You can see this is like roughly kind of what's being emitted from where, in terms of NOx species. The more important thing is probably that these species go into the atmosphere, they enter clouds, they then react with the water in the clouds, and you get nitric acid, or you're also able to get sulfuric acid, which then rains down onto us and the plants. So first of all, this harms soils. Biology is very like pH sensitive, so you can't change the pH that much, otherwise you start damaging things. So when you add more acid into things, it does just mess around with it and leads to a lot of things actually just dying. The other thing that this is an issue for is that there's a lot of toxic waste that exists in like places where mining is quite prevalent. So you get a lot of things like arsenic or aluminum in the that's so American, sorry, aluminium in the water. This is a very complicated graph, but basically when you add more acid, it goes this way, which means you end up with this specific arsenic coming up more often. This is quite problematic because it just free flows in the water as opposed to being like stuck to rocks and things. So you end up with more of these toxic metals within the water, which then leads to people drinking it. This often impacts developing countries a lot more because they don't have water filtration systems to the same extent, and they're not able to like combat these issues. So again, worth noting that a lot of the time, the people actually causing the problem are not the people affected by it in these instances. Now, eutrophication is another big issue, I guess. This is basically caused by nitrogen and phosphorus entering water streams. Basically, ammonia is like one of the largest chemicals produced. You can see it consumes 2% of the world's energy and 3% of the world's natural gas that we produce annually. So this is actually a very big process. We use quite a lot of nitrogen. 80% of that ammonia that we produce then goes into using fertilizers to kind of like just in agriculture in general, but only 46% of the nitrogen that we're putting onto crops is actually stays within the crops. So 54% of it just kind of gets washed away. And we don't really, well, we do know what happens with it. What happens with it is that you end up with things like this. You've probably seen things like this just kind of on your walks or whatever. This is actually what eutrophication is. It's like the development of large algal blooms, which kind of prevent other species from getting oxygen as a result of them. So this, again, does a lot of damage to fishing communities and harms biodiversity quite a lot. But you also get health issues such as blue baby syndrome. This is something where like babies just don't get enough oxygen. It's less. So the solutions to this are generally actually imposing things onto farmers, which is relatively difficult because especially in places where farming is quite like a large amount of farming happens, because it's difficult to like enforce rules on every single farmer. So it's quite difficult to do. It's also kind of unreasonable to ask them to do something, I guess, when it's kind of just mandatory that they have to make a living using nitrogen. The alternative is making better fertilizers, I guess, that don't kind of run off as much. Plastic, you all know what plastic is. This is kind of just a big problem. I'm sure you're all aware of it. I probably won't spend that much time on it. I just want to note that roughly we produce 50 kilograms of plastic per person per year. So that's kind of nuts. That's like your body weight in plastic for some people. And then if only 15% of this is recycled, so it says 400 million tons per year, if only 15% is recycled, that means that 340 million is not recycled. So you can imagine how that builds up. It's quite problematic in general. Moving on to something slightly different is demands for energy. I think this is generally happens when you either have countries that supply energy end up in tensions with other people. So see that Russia has obviously controls a lot of oil due to current political issues, current issues in general, people are not getting supply from Russia. So this probably has created some amount of energy like demands within countries that relied on Russia for oil. Regardless of that, within a lot of countries, the infrastructure just isn't there to a sufficient extent for the amount of like a growing population. So you end up with not enough energy being distributed to the places where energy is needed. This just causes harms for people because everyone kind of relies on energy nowadays. So you just kind of need it in some capacity. So you sometimes also end up with a reduced industrial output as a result of this. Lithium mining. You'll probably encounter lithium quite a lot in debates. I think it's relatively important. It's used in electric vehicle batteries, and this is the most important thing. The primary countries which export this are Australia, Chile, and China. These are like the three that are like notably more so than other countries. There are a couple of ways this is done. The main way is through something called brine evaporation, where you pump salt water where the lithium is up to the surface, and then you leave it in these big evaporation ponds for about a year, and then eventually the water kind of goes away and you're left with the brine, which has a lot of lithium in it. This is quite harmful because it does require some amount of chemicals to be used. The water that is pushed up and used is not able to be used for like drinking water or any other purpose like that. It's also quite an energy demanding process. Imagine pumping a bunch of water that's like completely under the ground back up to the surface. It's quite long, quite an energy intensive process as a result of this. So again, the main issue is trying to find a better way to do things. Yes, Josh?
Is it true that on net lithium mining is worse than the benefits producers?
So
It came up in a debate once, and I didn't know how to like explain that it wasn't true.
Roughly I think it's for every ton of lithium that's produced, it's roughly 15 tons of carbon dioxide which is produced. But that is still better than what is done in the fossil fuel industry. So generally you are better to be doing lithium. It still is not like the perfect fix, but it is a better alternative. So this thing called direct lithium extraction is kind of what is currently being suggested. About a week ago, there was actually something done in Cornwall where they were able to extract lithium from stones. So there's some progress being made here. The other thing is phosphorus mining. This is specifically not actually an environmental problem. I just wanted to bring it up. There is like a slight environmental issue where there is probably like some toxic and radioactive waste produced. That is kind of a problem. But the main thing is actually that Morocco in the Western Sahara, in that area, holds 70% of the world's phosphate reserves. So it's kind of controlled by a very small amount of countries. And then the production and actual like manufacturing to turn it into usable phosphate is again only controlled by 4 countries. So it's just worth noting that phosphate is necessary for agriculture. Again, this is used as a fertilizer. So it's just worth noting that these countries have a lot of influence in agricultures of other countries. I just think that's worth noting. Again, coming up with other fertilizers could probably solve this issue. Now, I've spoken a little bit about feedback loops during it. I think that feedback loops tend to be actually relatively intuitive when you're debating. You probably just realize that something leads to something else, which then kind of comes back around. So this is specifically for climate change examples. When you melt snow and ice, because the temperature gets higher, you lose ice, then more things are actually absorbed because ice is actually reflective of radiation. So you end up with more radiation being absorbed. This means things get hotter, which then means that more things melt. Like it's just a cycle of itself. This is positive feedback because it exacerbates, like it keeps forcing the issue that started it basically. In terms of negative feedback, higher temperatures lead to water evaporating more. You do actually get more clouds as a result of this. And then this actually blocks reflectivity. You can see that it's quite easy to come up with feedback loops on either side of things. And there are other examples, I guess, in terms of when you invest in like mining as a country, you probably neglect other industries, and these industries kind of start to fail as a result of this, which then means that you are contingent on investing more in mining. Mining also harms other industries like the surrounding area in terms of land use. So you probably get more cycles like this. Tipping points are kind of only relevant in climate change debates because it's difficult to quantify things in other debates to a specific moment in time. So this is the West Antarctic ice sheet. This is like the biggest thing that you can mention probably in regards to climate change. Some people think that this has already been hit as a tipping point. Some people say there's like another 0.5 degrees to go. So you can use this however you want, I guess. This is a very horrible, I think, looking thing of potential tipping points. You can see the ones that are highlighted as like the most immediate threats are specifically ones regarding ice sheets, are the main ones, rising sea levels. This is probably all like within like 0.5 degrees of something happening that you probably get all of these melting, basically. Other ones worth noting are probably also anything about circulation, because this means that the temperature across the world doesn't actually equalize as well, which means you do get these accumulations of temperatures in certain areas. I'm not going to take questions. I'm really sorry, that was very information dense, but you can ask me later about any of it if you want. Right, quickly on research funding. This is the main ways that the government will fund things. So they do individual grants for projects where they say, hey, we want you to make something that solves this issue with like carbon dioxide or whatever, or we want you to come up with a better way to synthesize something that is currently not done very well. They take them all in, you submit proposals, they take them in and they're like, this is good, we'll give you some money, this is bad, we won't give you money. That's kind of how they do it. The next way that they do it is block funding. This is normally like, they're like, this university is doing a lot of good work, they're producing a lot of things, so we're just going to give them like a lump sum of money. They can do whatever they want with it. That's just kind of how that works. And the other thing is that the government takes its own money and then funds things that they run. So national labs, other things like defense funds are often kind of examples of this. So project grants, what are the pros of this? Normally it means that the government is able to strategically force people to invest in certain things. Like you get specific research and things. So things like climate change, if the government sees that as an issue at the time, they can kind of direct research to go into this specific field. And this has a knock-on effect of what, actually I'll discuss that later. So the other thing they can do is use this to inform government policy. So if the government wants to pass a law on something or a policy on something, they can make sure that there's enough research done beforehand so that it goes on, basically. The cons of this is that it means that researchers or institutions aren't able to freely choose what they do to the same extent, because to get the money, you have to be doing things that the government wants you to be doing. So you get less of that. The other thing is that it takes a lot of time to process all these applications, because a lot of people want the money for their research. So you end up with it actually taking a lot of time for people to get the money and solve the problem in the long term. So block funding. This is the exact opposite, where you get extreme amounts of autonomy because you're able to do long-term planning. Maybe your project takes a couple of years to do. So you get the money, you're able to plan around this, essentially. The other thing is that this is not government. The government isn't telling you what to do with it, which means that you can develop things that maybe are core infrastructures that aren't actually going to serve short-term like benefits for someone. So you probably get more research into things that are just more novel. This is just kind of helpful for people like this. The cons are that sometimes this isn't very applicable in the moment. It kind of takes a while to see a return on investment a lot of the time. So there's less of a guarantee of that. And I guess that the way that the funding is allocated is the universities get money based on how good the research quality is. So they get funded, which then means the research quality gets better, which means they get funded again. So it just kind of is a self-repeating cycle. This is also an example of a feedback loop, I guess. Government-performed research is quite similar to institution, like giving specific project grants. There's not much of a difference here. The main difference is that it's easier for the government to pivot on things because they're able to just be like, this doesn't serve our purposes anymore, immediately redirecting funding, as opposed to if they've already given money for something, they're not able to just take that money back. I guess also the governments are better able to communicate with other governments on like international issues. The private sector is completely different. You probably understand how the private sector works. Basically, you just sell a product and then the product's what's going to make you money. You can also make money off of things like patents, which I'm going to discuss in just a minute. And then also investments, where just like, if your company looks pretty good on paper, people are probably willing to give you money because you've done something good once before, so they're willing to trust that you're going to do something good again, basically. Notably, the public sector and the private sector do influence each other quite heavily. So the government can do similar things in the private sector, where they kind of give direct subsidies to research that benefits them, or give tax breaks to companies. And this is very appealing to companies in the private sector who care about profit. Basically, the public sector does a lot of foundational research, which when this is done, it is then lower risk for the private sector to go and do something because they know that there is a means to an end, because the first bit's been done for them, basically. So they know that there is like something they can get out of doing this research. The private sector then produces these products, which then the public sector uses to then do better research. Like, again, it's all cyclical. So they do actually benefit each other. Right. Quickly on patents. Sorry to anyone who's done law. The patents in here, the law section is probably not accurate, but oh well. Briefly, what are patents? So intellectual property is just anything that is not physical, like actual property, I guess, anything that you've kind of came up with as a result of innovation. Patents are what are described as negative rights. They don't actually give you the permission to do anything. It just means that you have the permission to tell other people not to do things. So in the same capacity, when you own a car, it doesn't mean it just like that you're allowed to drive the car, just because you would need to also have like a license, things like this. There's other people just can't step in your car and drive it. It's kind of similar in principle. The other thing in terms of like terminology is that the specification is the written description of what you are trying to patent. And the claims are specifically what is protected by the patent, and you need to use precise language when you make these, generally, because otherwise they kind of get misconstrued. So this is the patent application process. It's quite long, very arduous. This is for anything that's in the Paris Convention, which basically just says that if you develop like if I was to submit a patent in the US, because the US and the UK are both in the Paris Convention, my patent is treated like the same in the same level of someone who is a US citizen, basically. And that's all it means. So you submit your patent to this like patent cooperation treaty. They kind of then give a written opinion on like vaguely how they think it will do. You can then also have optional examinations that you kind of pay for to see if you think the patent will succeed in specific countries. Then at that point, you decide which countries you actually want to do it in, because you have to pay for the translation fees to other countries. So if you actually think it's not going to benefit you to, say, have a patent in like Uganda, then don't pay for it to be translated to whatever languages they're going to speak in Uganda. So like, just don't actually, this is the point where you decide where you're actually going to kind of have your patent. Then it goes to the specific countries after 30 months. This has been a long process. And then probably after like 18 months after that, you will then secure a patent. So it can take up to 4 years for you to actually get a patent in some countries. This is quite long. You're also not allowed to publish your research before you would have received this patent. So that's worth noting. These are things that can be patented. Take note or don't take note. The most important things for science generally are machines and compounds are probably the most, and processes, I guess, are the most important things there. This is the criteria for patents. You have to do something that is novel. So this is why you're not able to do prior publication of things. You have to do something that is non-obvious. So something that anyone who has like an undergraduate degree probably in that field wouldn't have like thought on just on the spot, like logically. So it should be something actually innovative. In terms of utility, it must have some type of application or will be able to be applied in the future. Disclosure and claims are other things that are just kind of necessary within the patent actual application process. These are not things that are specifically required of the invention, but just things you're going to have to do, as I mentioned earlier. This is quite complicated. I've made this really fun example with Tom and Zainab. Neither of them have bothered to show up. So basically, the way this works is just that you can make something and basically loan your patent to other people in exchange for like 10% of the profit on anything that they make with this. This actually didn't require a huge explanation that I've given here. It's just as simple as like loaning something and expecting something in return. There are ways to bypass this in some capacity where, for example, I've said that Zainab would sell this and Tom would get 10% of the earnings. if Zainab's able to somehow donate this and then like make profit and like exportation fees, then Tom wouldn't get anything. So sucks to be Tom in that situation. The main thing that you'll discuss patents for in debates are in terms of innovation. So the main things are that you have to disclose what you're doing. So other people are able to see kind of what's just happened, like what is new within the field, and then can build upon this work, as opposed to you hiding it. Also, patents are cited to get other patents. So you have to kind of use other patents, what they disclose, to then get information. The next thing is then protection. So this means that they're more likely to get investors because other people are not going to be able to make the same thing. So more people are willing to invest because they know that you're the only one who can do that specific thing. And lastly, in terms of profit, this is kind of a similar thing, but you're more likely to try and make something new that people actually want. So people will buy this. So then you have more money to kind of put back into the system. However, you can also argue that this is bad for innovation. So applying for these things are often quite expensive. So if you're not able to apply for a patent because you're a small company or your patent lawyers aren't particularly good or whatever, so your work won't be defended very well. It means that you just don't get these patents, which then just means someone steals your work and like there's no innovation there, nothing new. Restriction also patents can, if you have good patent lawyers, you can kind of make something quite broad so that other people kind of feel like they're almost forced to infringe upon it. So you limit creativity because it's already been covered by another patent, so you don't actually bother to like look into it and you don't do anything about it. So it's difficult to use like new things. And the other thing is like exploitations of the system. So there are examples specifically in terms of patent dodging. This is very prevalent in pharmaceutical industries where things like when Viagra first became a medicine, there are at least 2 or 3 versions of basically just Viagra, but with like slightly different functional groups on the end. But you can still use them because they're not covered by the original patent. There's not actually anything new being made here. It's just the fact that you're actually able to just take the same thing. You'll see similar things with like Mounjaro and Ozempic are basically the same drug, but they're not actually like covered by the same patent. The other thing is that you do sometimes get companies which are apparently called patent trolls, which I think is kind of crazy, who specifically look out for infringements. Again, a lot of companies which have kind of a lot of money will have good patent lawyers who are looking out for infringements. Am I done? Yeah, thought so. Does anyone have any questions on that? Great. Oh, fuck. Yeah, this is basically just the difference between private and public patents. So public patents tend to actually be like the basis for future work. So they're often cited for other patents, whereas private patents tend to capitalize on things that are commercializable, if that's a word. And then in terms of impact, similar thing, where public patents tend to have more spillover. So like NASA funded a thing on microactuators, which can be used in multiple different fields. Whereas private patents tend to be on things that are very specific to the field, things like medicines, which are only really going to be used as a medicine. Like there's no other reason for them. Right. Thank you.